We are moving on to Unit 13, Lesson 1, talking about ratio and proportion again. Okay, and your objective is to solve proportions. Now this isn't like regular or like proportions we've done before. They've been really easy, okay, so don't get the idea that it's going to be a piece of cake. I mean, it's not hard, but it is an extension of what you already know about proportions, okay? So we need to introduce something called extraneous solutions here. Extraneous solutions are solutions that you get that do not satisfy the original equation. Okay, so for example, sometimes when we change an equation, alter an equation to solve for a letter, okay, we end up getting solutions that don't work for the equation that we started with. Okay, so for example, we have learned before that if I do something to one side of the equation, I can do it to the other side and not change the original value. Okay, so let's take this x equals 3 for example. I know it's already solved for x, but let's change it. Okay, let's do the same thing to both sides. What happens if we square each one of these sides? Okay, so let's say that I square each one of these sides, so I get x squared equals 9. Okay, again, that happened by squaring each side. So we squared each side. Again, we can do that because we did it to both sides. We did the same thing to both sides of the equal sign. Okay? Now let's say I went ahead and tried to solve this equation for x. Okay, so I squared both sides. Now let's say I try to solve it for x. So I'm going to take the square root of each side. Okay? Well, the square root of x squared is x, and the square root of 9 is plus and minus 3. Okay, positive or negative 3. So I have two solutions to this one. Well, if I plug each of these solutions back into the original equation, okay, I get x equals 3 and x equals negative 3. Okay, for my answers. Okay, for my solutions. So again, if I plug 3 in for x, I get 3 equals 3. And if I were to plug my negative 3 in for x, I get negative 3 equals 3. And that is not true. Okay? So I did the same thing to both sides of the equation and then resolved it, and I ended up with an answer that does not satisfy the original equation. So this is extraneous. Okay, this one does not work. Okay, so that's what an extraneous solution is. And that happens when we square an equation. Okay? And so we're going to solve some proportions, okay? And we need to make sure that we check for extraneous solutions, because again, that can happen, okay, when we end up squaring each side of an equation, for example. Okay? So again, we're going to solve proportions, we're going to solve for x, and then we have to make sure at the very end we check the answers that we get to make sure that they both work, or all of them work in the original equation. Okay, so let's go ahead and solve some of these proportions. Okay, instructions say solve the proportion and check for extraneous solutions. Well, we're going to solve proportions like you've learned to always solve proportions by using cross products. Okay, so we're going to use cross products here to solve the proportion. Well, if I take x times x, that's x squared. And if I take 3 times 12, that's 36. Okay? So we did cross products to start with. Again, I'm just going to go ahead and write the steps here just so we understand from our notes what happened. Okay? Now we know that we solve an equation squared by taking the square root of both sides. So I get x equals plus and minus 6, positive and negative 6. So we found the square root. Okay? So here's our solutions. X is plus or positive 6 and negative 6. We need to make sure that both of those work in the original equation if we plug it in for x. Okay, so let's check. If we plug in 6 to the original equation anytime we see an x, this is what I get. Okay, 6 over 3 equals 12 over 6 because we plugged in 6 for both x's there. And we want to know, does that work out? Well, 6 over 3 is 2 and 12 over 6 is 2. Okay, so we know that positive 6 works. Now let's see if negative 6 works when I plug it in. So we got negative 6 over 3 equals 12 over negative 6. And negative 6 divided by 3 is negative 2. And 12 divided by negative 6 is negative 2. So this works, each one of those solutions works. So that is, in fact, the two solutions. We have no extraneous solutions, okay, because both of the solutions, positive and negative 6, work for the original proportion that we had. Okay, so again, no extraneous solutions there, they both work. And we have one more example to do. Okay, directions here, again, say solve the proportion, check for extraneous solutions. Notice there's a lot more stuff here, okay? Again, these are the kind of proportions I was talking about, where they're not all that easy to just look at and try to solve, okay? But we're going to go ahead and use the methods that we've learned all throughout the year to go ahead and solve these, and they're really not that difficult, okay, even though it looks pretty messy. So again, anytime we solve a proportion, we're doing cross products, okay? So we'll do cross products here. Now we're taking 2 times y squared minus 9. We're taking 2 times this whole thing. So this part needs to stay in parentheses. So I'm going to rewrite that as 2 times y squared minus 9. Looks like that. Equals, and we're doing y plus 3 times y minus 3. Well, again, y plus 3, the whole thing, times y minus 3, the whole thing. And that was our cross products. Okay, now I'm going to go ahead and rewrite things as adding the opposite. So we're going to have 2 times y squared plus negative 9 equals y plus 3 times y plus negative 3. Okay, so again, we just changed subtraction to addition. Now we can't leave this looking like this. We've got to simplify. Okay, we're always simplifying things as much as we can to make things easier. So we're going to distribute here. Okay, so 2 times y squared plus 2 times negative 9. And we look at this here. We're multiplying two binomials. So what method have we learned for that? We've learned FOIL. Remember FOIL man and FOIL cat. So we're going to take the firsts and multiply them. Y times y is y squared. Plus the outers. Y times negative 3 is negative 3y. Plus the inners. Positive 3 times y. Plus the last. 3 times negative 3 is negative 9. So again, we FOILed these two binomials here. Now we can't leave this side looking like this. We've got to combine our like terms. Okay, this side over here has no like terms to combine, so I'm going to rewrite it. 2y squared plus negative 18 equals, now I can combine the like terms. Well, we got y squared, and then negative 3y and positive 3y cancel, so it's just y squared plus negative 9. Now we could have gotten this in our head from using, again, this is the sum and difference pattern. Okay, remember where it ends up being just a squared plus b squared. So a squared minus b squared. So it's y squared minus 9, which is the same as y squared plus negative 9. Again, that was one of those special products that we learned. We could have just done that, but if you don't remember, you can always FOIL. Okay? Well, now we got variables on both sides here, so we need to tackle the variables on both sides. Whoops. Sorry, I didn't mean to write that. Just ignore this little thing here. We attack variables on both sides by getting them on one side. So I'm going to go ahead and subtract y squared from each side. Just like when they were regular variables, okay, just a y or whatever it is. Y squared minus y squared cancels, that's what we want, so we only get variables on one side. 2y squared minus y squared, well that's just 1y squared. Plus negative 18 equals negative 9. Now we're going to add 18 to both sides and get y squared equals, and negative 9 plus 18 is 9. And we're going to square root and get y equals positive 3 and negative 3. Okay? Now again, we're used to boxing our solutions or circling our solutions. However, okay, we have to make sure first that both of these solutions actually work for the original problem. Okay? Because if it doesn't, then we have an extraneous solution, and we have to take that into account. So before I box these answers, I got to check them and make sure they both work. So I'm going to plug in positive 3 to this original equation here. Okay? So which means, again, I'm going to go ahead and change my pen to red for the checking stuff. So positive 3, so that's 3 squared minus 9 over 3 plus 3 equals 3 minus 3 over 2. So again, all we did is we plugged in 3 whenever we saw the y's. And now we just need to solve this. Well, 3 squared minus 9, that's 9 minus 9, that's 0. Over 3 plus 3 is 6. And then over here we get 3 minus 3 is 0 over 2. So we get 0 equals 0. So that checks out. So we know that positive 3 is a solution. Okay, now we need to check negative 3. And we're going to plug in negative 3 for the y's now. So I'm going to have negative 3 squared minus 9 over negative 3 plus 3 equals, and the other side was negative 3 minus 3 over 2. And see if that works out. Well, negative 3 squared, that's negative 3 times negative 3, that's still 9. Minus 9 is 0. And 0 divided by anything is 0. Okay, because we're going to have 0 over, and then negative 3 plus 3, which is 0. Okay, so again, we'll write that down. Negative 3 squared is 9. Minus 9 is 0. Over, and now negative 3 plus 3 is 0. And over here I get negative 3 minus 3. Well, negative 3 plus negative 3 is negative 6 over 2. Now look at this. I get 0 over 0 equals negative 6 over 2. Two problems there is I can't divide by 0, so this answer is undefined. And then over here I get negative 3. So I would have undefined equals negative 3. That does not work. Okay? Which means that negative 3 here is an extraneous solution. It does not work, even though we solved all this and got negative 3 for a possible answer. It does not work for the original equation when we solve it. So the only answer then is positive 3. So it's y equals 3. Again, because negative 3 is extraneous. So it is very important that you check your answers and plug them back in and make sure they work for the original equation. Alright, that's your lesson on ratios and proportions and extraneous solutions. Happy homeworking.